Okay, let us start. How to solve a system of linear equations. How to solve system of linear equations. System of linear equations. So, what is the system of linear equations? You know, linear equation means a equation which is in linear form. Linear form means the degree of its variable is maximum 1. That means it may be 0 or 1, but may not be more than 1. And this is not only a linear equation, this is a system of linear equations. Now consider a system of linear equation. Consider a system of linear equations. Consider a system of linear equations having consider a system of consider a system of m linear equations having n unknowns. Okay, now consider a system of m number of linear equations having n unknowns. So that is your a11x1 plus a12x2 dot 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 to am1 an1 an1 xn. This thing, suppose your b1. Similarly, the second equation is a21x1 a22x2 dot dot an2 sorry a11x1 a12x2 then a1 and xn, and the second equation is a21x1 a22x2 plus dot dot up to a2n xn. Suppose this is your b2. Similarly, the mth equation, because since there are m number of linear equations, so the mth equations will am1 x1 am2 x2 plus dot dot up to amn xn. This thing equal to bm. So you may correct it from your note. It is written bn there, but that is your bm. So this is a system of linear equations. So which consists of m number of, this is the number 1, this is number 2, this is m number m. So there are m b1 b2 up to bm. There are m number of linear equations and n unknowns, because this is x1, this is x2, similarly this is xn. So if I write this system of equations in matrix form, then this will be your a11 a12 like a1n. That means the coefficients in first row I have written the coefficients of x1 x2 up to xn in first row from the first equation, and from the second equation, if similarly I will write the coefficient, this will be your a21 a22 dot dot up to a2n. Similarly, for last one, this is your am1, am2 dot dot up to amn. This is a m cross n matrix, and this one is your x1 x2 dot dot your xn, and the right hand side is your b1 b2 dot dot bm. This is an m cross n order, this is of n cross 1. So after multiplication, this is your m cross 1 order. And what you are getting this matrix, this is called matrix A, which is named as coefficient matrix, because these are the collection of coefficients of these variables. This is called a coefficient matrix. And the middle one is your x, that is the variable set, or this is a column matrix which consists of variables. That's why it is called variable matrix, or we can say unknown matrix, because these variables are unknown to you. That's why it is variable, so its name is variable matrix or unknown matrix. And the last one, these are constants, so ax, this thing equal to b, and we call this as constant matrix. So our above system of equations, the system of linear equations, can be reduced to this form: ax equal to b, that means it is reduced to a matrix form. And if all the bi, whatever your bi is, for I equal to 1 2 3 4 up to m, if any bi is not equal to 0, then this system of equations is called non-homogeneous. If any bi is not equal to 0 for I equal to 1 2 3 4 up to m, then the above system of equations, then the above system of equations are called non-homogeneous system of equations, that is NH. So if b is equal to 0, b means the whole matrix b, the a whole matrix b, or the column matrix b is equal to 0 means each entry of this matrix are 0. So if b is equal to 0, that means if it is can be written as ax equal to 0, then it is called a homogeneous system of linear equations. Homogeneous system of linear equations. That means this thing can be written as like this: a11 x1 plus a12 x2 up to a1n xn equal to 0. Similarly, a21 x1, a22 x2 up to 2n xn equal to 0. And the last one is am1 x1 plus am2 x2 dot dot amn xn is equal to 0. This is a homogeneous system. And if the right hand side is non-zero, then that is a non-homogeneous system. So now we know what is a homogeneous system of equations and what is a non-homogeneous system of equation. Now our next time is how to solve a system of equations, whether it is homogeneous or non-homogeneous. So how we will solve it? So here we know there are three matrices. One is coefficient matrix, another one is variable matrix, and another one is your constant matrix. Also there is another matrix, like if we will consider a comma b, which is the combination of this coefficient matrix and this constant matrix. This is called augmented matrix. This is called your augmented matrix. X comma b is your augmented matrix. Then now how to solve it? So in our last class we know already how to find the rank of a matrix. So if a rank of A is equal to rank of this coefficient matrix is equal to rank of this augmented matrix, then solution of the equation star, solution of the system of equations star, what I have given the system of equation as star exists. So if rank of A is equal to rank of AB, that means rank of coefficient matrix equal to rank of augmented matrix, then the solution of star exists. That means we can say that the system of equations star is consistent. So consistent means the system of equations has a solution. Similarly, if rank of A is not equal to rank of its augmented matrix, then solution of star does not exist. So we can say that star is inconsistent. That means it has no solution. Inconsistent. Okay. So now case arises if it is inconsistent, we can say that the star is not consistent. That means you are inconsistent. Okay. Now we can say that if it is consistent, that means it has a solution. So if it has a solution, then it has a unique solution, or it has a infinite many solution, and that may come under the consistent part. No, inconsistent means no solution. But if it is consistent, so there are two cases, whether it has a unique solution or it has infinite solution. Like this, solution means consistent or inconsistent. And then consistent means it has a solution. So if it has a solution, then it has a unique solution, or it has infinitely many solution. So it is consistent means suppose if I will take, let rank of A equal to R and your rank of augmented matrix A comma B, suppose this is your R1. So it is inconsistent means R is not equal to R1, and it is consistent means R is equal to R1. And then when it has unique solution and when it has infinitely many solution, it has also there are also some ideas. If it has a unique solution, or if it has a infinitely many solutions, and I already told you A is a matrix of order m cross n. So if I will consider the augmented matrix A comma B, then extra one column is added there. So it is a matrix of order m cross n plus 1. So whatever it may be, I told you in the last class, if A is a matrix of order m cross n, then rank of A plus nullity of A means rank of A plus nullity of A equal to the number of columns of that matrix, that is equal to n. Since this is a m cross n order, so it has m number of rows and n number of columns, so rank of A plus nullity of A should be equal to n. So when this system of equations has a unique solution, so if it is a homogeneous solution or if it is a homogeneous equation, so its unique solution means only the trivial solution, because this is a homogeneous equation. And if you will say it has unique solution, you know the system of equations has a unique solution means since it is a homogeneous equation, if this is a homogeneous equation and I am saying it has a unique solution, that means if you will put x1 as 0, x2 as 0, then xn as 0, means each x is at 0, then obviously it will satisfy, because a11 into 0 is 0, similarly a12 into 0 is 0, similarly a1n into 0 is 0. So a homogeneous equation has a trivial solution or a unique solution means x1 equal to x2 equal to xn equal to 0. The unique solution means it has the trivial solution x1 x2 up to xn equal to 0. So if it is, leave this thing. So when it has a unique solution, whether it is homogeneous or non-homogeneous doesn't matter. So when it has unique solution, if R is equal to R1 equal to n, so what is the number of columns of that matrix? A number of columns means I already told you this x1 x2 up to xn, the number of variables. Here n is the number of columns of that matrix and there are n number of variables. So if rank of coefficient matrix equal to rank of augmented matrix is equal to the number of variables or the number of columns present in the coefficient matrix A, then it has unique solution. And when it has infinitely many solution, if R is equal to R1 and this thing is less than n, R is equal to R1 but this one is less than n, at that time it has infinitely many solutions. So these are two conditions when if it is consistent, that means if it has a solution, then when it has a unique solution and when it has a infinitely many solutions. So if the rank R equal to R1 is less than n, then what will be its kernel? Kernel means what is its nullity? So its nullity is equal to, because if rank of A equal to R and this one is your n, so this one will be your n minus R. So your nullity is your n minus R. That means it has infinitely many solutions of dimension n minus R. So if it has infinitely many solution, then this infinitely many solution, the infinitely many solution has a dimension n minus R. Okay, these things you remember, and then we will come to a particular, then we will consider two problems where there is a unique solution and where there is a infinitely many solutions. And I have given you a table in your note. You can follow these things. So now consider a problem. Consider a system of linear equations. system of linear equations. The system of linear equations is 2x1 plus x3 minus x4 2x1 plus x3 minus x4 plus x5 equal to 2, and then x1 plus x3 minus x4 plus x5 minus x4 plus x5 equal to 1. The last one is your 12x1 plus 2x2 plus 8x3 plus 2x5 plus 2x5 is equal to 12. Okay, this is a system of equations where there are 3 equations and 5 unknowns. So now what I will do, first I will check whether it is consistent or inconsistent. So how we will check it? We have to find the rank of this coefficient matrix and the rank of augmented matrix. So now write the corresponding augmented matrix. Now the corresponding augmented matrix is given by the corresponding augmented matrix is given by, so what will be its corresponding augmented matrix? So this will be your, first write the coefficient matrix, or you can write 2 0, just writing the coefficients 2 0 1 minus 1 1, then by I am doing the separation by dotted line, this is 2, then next row is 1 0 1 minus 1 1 1, then the third row is 12 2 8 0 2 12. So this is your corresponding augmented matrix. Now you know how to find the rank of that matrix. How you are finding? Just making the row reduced echelon form. Try to make it in the reduce it in the row reduced echelon form. So in the row reduced echelon form, first we have to make the first entry of first column, first entry of first row into 1, but this is 2, and in the second row there is a 1, so we can interchange it. That means interchanging row 1 and row 2. So after interchanging, what you will get? This is your 1 0 1 minus 1 1, then 1, and the second row is, this is your 2 0 1 minus 1 1 2, and your third row is as it is, your 12 2 8 0 2 12. Okay, so now the first entry of first row is converted into 1. Now what we will do? Now go to, and now we will make the other entries of this column into zeros. So what I will do? I will do this thing. Now row 2 changes to row 2 plus minus 2 times row 1, and row 3 changes to row 3 plus minus 12 times row 1. So I will make these changes. So row 2 changes to row 2 plus minus 2 times row 1. So what is my row 2? Row 2 is your 2 0 1 minus 1 1 2. This is your row 2. Then this is your row 1. Then minus 2 times row 1 will be minus 2 0 minus 2, then plus 2 minus 2 minus 2. So this is your 0 0 1 minus 2 is minus 1, this is plus 1, this is minus 1, this is 0. So write this thing. Row 1 is as it is. This is my row 2. So row 1 is your 1 0 1 minus 1 plus 1 then 1, and your row 2 is what I got here. This is your 0 0 minus 1 plus 1 minus 1 0, and the third row is make the changes. Third row is 12 2 8 0 2 12, and then minus 12 times row 1. This is your row 1, then multiply minus 12. So this will be minus 12 0 minus 12, then plus 12, then minus 12, then minus 12. So what we got? This is 0, this is 2, this is minus 4, this is 12, then this is 2 minus 12, which will be minus 10, then this is 0. So this is your 0 2 minus 4 12 minus 10 and 0. So if you are getting this thing, then now I did the first step, that means the 1 0 0. Now next time is to make the second column as 0 1 0. That means we have to make this element as 1. So how will make it 1? There is a element 2 is here. So first I will interchange it, then I will multiply half. So now interchanging row 2 and row 3. So this will be my row 1 is as it is. So first write row 1 1 0 1 minus 1 1 then 1, and the second row is, now I am interchanging row 2 with row 3. So this will be my 0 2 minus 4 then 12 then minus 10 and 0, and the third row will be 0 0 minus 1 then 1 minus 1 0 1 minus 1 0. Now there is this element is 2. Now I will multiply half so that it will convert into 1. So now row 2 changes to row 2 into half, and row 1 is as it is. This is your 1 0 1 minus 1 1 and 1. Then row 2 after multiplication half, it will be 0 1 minus 2, this is 6, then minus 5 0 minus 5 0. So देखो था मतलब भूल ले कहबो. Then third row is as it is. This is your 0 0 minus 1 1 minus 1 0. Now first row is your 1 0 0. Sorry, first column is your 1 0 0. Second column is your 0 1 0. Now next step is to make the third column as 0 0 1. So first I will make this entry as 1. So I will multiply minus 1 so that it will become 1. So now row 3 changes to row 3 into minus 1. So first two rows are as it is. So this is 1 0 1 minus 1 1 then 1. Second row is 0 1 minus 2 6 minus 5 0 6 minus 5 0, and in third row I am multiplying minus 1. So this will be 0 0 plus 1, then minus 1 plus 1 0, minus 1 plus 1 0. So now this thing is converted into 1. Now I will make the other entries of this column into zeros, so that's why I have to make these changes, like row 1 changes to row 1 plus minus 1 times row 3, and row 2 changes to row 2 plus 2 times row 3. So what is my row 1? This is your 1 0 1 minus 1 1 1, and your minus 1 times row 3 is your this is your row 3. So minus 1 times row 3 means this is 0 0 minus 1, then plus 1, then minus 1 0. So what you are getting, this is 1 0 0 0 0 1 1 0 0 0 1. This is 1 0 0 0 0, then 1. Similarly, what will be our second row? Second row will be row 2 plus 2 times row 3. So first write row 2. This is your 0 1 minus 2 6 minus 5 0. Then 2 times row 3 is your 0 0 2 minus 2, then 2 0. This is your 0 1 0 4 minus 3 0. So your row 2 will be 0 1 0 4 minus 3 0 4 minus 3 0, and third row is as it is. This is your 0 0 1 minus 1 1 0, and this thing further cannot be reduced because there are only 3 rows. That's why we got already 1 0 0 0 1 0 0 0 1, and there are no other rows. If there are another rows, then we have to make this entry as 1 and other entries of this column into zeros. So this is the row reduced echelon form, and further it cannot be reduced. So what is the since this is the row reduced echelon form, then what is the rank of this matrix? What is written on this box? This is for A. This is for matrix A. What I have written here, 1. So these things are coming from matrix A, and what is its rank? Its rank is 3, because the rank says the rank means the number of non-zero rows present, the number of non-zero rows present after row reduced echelon form. Now it is the required row reduced echelon form. The rank is 3. So if you will consider this augmented matrix, that means the whole matrix, so it has also rank 3. So if I will say the rank of augmented matrix is R1, then R1 will be 3. That means your R is equal to R1. That means it has a it has a solution. So you got or not how the rank of the augmented matrix and rank of the coefficient matrix are same? Here the both are same and both are equal to 3. So if you have any doubt, then you can ask me. So system of equations has a unique solution. Has a solution. That means this is consistent. That means the system is consistent. Now find its solution. So if it has a solution, then write down the solution. Now, similarly, how we are getting from a system of equations into matrix form. Now we will convert this matrix, that means the row reduced echelon form matrix, into the corresponding system of equations. So now if we will go to the corresponding system of equations, so this is your row reduced echelon form matrix. So now change now now writing the corresponding now writing the corresponding system of equations from the above row reduced echelon form, from the above row reduced echelon form matrix. This is your row reduced echelon form matrix. So if you write the corresponding system of equations, it will get the first row is 1 0 0 0 0 1. So we can write it 1 into x1, 0 into x2, 0 into x3 plus 0 into x4 plus 0 into x5 is your 1. Similarly, from the second row, you can write this is 0 into x1, 1 into x2 plus 0 into x3 plus 4 into x4 plus minus 3. So remove this thing. Minus 3 into x5 equal to 0, and from the third row you can write this is 0 into x1, 0 into x2, 1 into x3 minus 1 into x4 plus x5 equal to 0. So this is the system of equations we get from the row reduced echelon form matrix. Now it is easy to find the unknowns from this system of equations. So from first equation, what we got? Your x1 is 1, and from the second equation, what you can write? Your x2 plus 4 times x4 minus 3 times x5, this is your 0, and from the last equation you can write your x3 minus x4 plus x5 equal to 0. So x1 is your 1. Now in this both the equations there are x4 and x5, so you can write 1, it's okay, and you can write x2 and x3 in terms of x4 and x5. So x2 can be written as minus 4 times x4 plus 3 times x5. Similarly, x3 can be written as this is x4 minus x5. So we got these things. So what is your system of, and now what are the solutions you got here? This is your, and you know your solution x is x1, x2, x3, x4, x5 transpose, because this is written in a column matrix. Okay, that's why since I have written it in a row, I have given the transpose. So this thing can be written as, in place of x1 we can put 1, in place of x2 in place of x2 what you will write? Here x2 is this much. What is your x2 is minus 4 times x4 plus 3 times x5 Similarly, your x3 is x4 minus x5, and x4 is your x4 and x5 is x5. This thing transpose. So how will write? See here, there are three things. One is a constant is there, and another two are x4 variable is there and x4 variable is there. So we can separate it. Where I write? Okay, I am writing here. So I am writing all the variables. So in first thing I am separating 1, then there are no constants, so I will put 0. Then if I will separate for this variable x4, then in first coordinate there is no x4, so I can write 0. Then second coordinate there is minus 4x4. In third coordinate simply x4. In fourth coordinate there is 4, so it will be 0. Then I will write for x5. So in first coordinate there is no x5. In second coordinate there is 3x5. Similarly in third coordinate minus x5. In fourth coordinate no x5. In fifth coordinate there is x5. So we can add this is 1 0 0 0, and if we will take common, then what will happen? X4 0 comma minus 4 comma 1 comma 1 comma 0. Similarly we can take x5 common. This will be 0 minus 1 0 1. Okay, so this is the answer. So if you will write this thing, you may write this thing as here 1, this thing are constant 0 0 0, and you can write span of, I am removing this transpose. So 1 0 0 0 plus since there are x4 and x5, so you can put any real number here. That's why I will write this is the span of 0 for 1 1 0 3 minus 1 0 1. So this is the required solution. So in place of x4 and x5, if you will put any real number, then this will give you a solution. Okay, and so it has infinitely many solutions. In place of x4, if you will put 1, if you will put 2 3 4 any real number, or in place of x5 if you will put any real number, then this will give different solutions. But these are solutions, that's why it has infinitely many solutions, because here you got the rank is equal to rank of coefficient matrix equal to rank of augmented matrix equal to 3, but it has number of columns. How many number of columns? This matrix A has 5 number of columns. This coefficient matrix A has 5 number of columns, so it has nullity 5 minus 3, which is 2, which 2 means these two, span of this one plus span of this one, and this is a constant solution. This is a constant solution, and since there is two variables x4 and x5 is there, so this is the span of these two things. That's why this matrix. Okay, so this is the solution. What we got this thing? This is the solution, and it has this infinitely many solution. So if anyone have doubt in this problem, you may ask me, or we will do another problem which is inconsistent. This is a problem which is consistent, that means it has a solution and it has infinitely many solutions. I know you don't have any any problems or doubts. So let's come to next problem. Solve the following system of non-homogeneous equation. This is my example. Solve the system of non-homogeneous equation. Solve the system of non-homogeneous equations. So now writing this equation, plus 2x2 plus 4x3 plus x4 equal to 4. And the next equation is 2x1 minus x3, 2x1 minus x3 minus 3x4 equal to 4. Then x1 minus 2x2 minus x3 equal to 0. And the fourth one is 3x1 plus 2 minus x3 minus 5x4 is equal to 5. Now this is a system of non-homogeneous equation. It is non-homogeneous because the right hand side, in the right hand side there are non-zeros are there. If at least one of them is non-zero, then this is a non-homogeneous equation. Okay. So what is our first time? First time is to write the corresponding write the corresponding auxiliary, corresponding augmented matrix. Now in this first step of its solution, writing the corresponding augmented matrix. Writing the corresponding matrix, that is your 1 2 4 1 then 4, and second 2 0, since there is no x2, that's why its coefficient is 0. So 2 0 minus 1 minus 3 and 4. Then third row is 1 minus 2 minus 1 0 0. Then last one is your 3 1 minus 1 minus 5, and it is plus 5. So our first time is to make the first entry 1, already 1. So I will by using, actually what we are doing this entry as 1, this entry is called pivot element. In each entry we are making in many steps we are making something 1, and that 1 is called the pivot element, and by using that pivot element we are making other entries of that column into zeros. That means for first column, if I will make these 3 entries into zeros, I am using by using the pivot element. By using this pivot element, we are making the other entries into zeros. That means the pivot element is in row 1. So with the help of row 1, we are making the other entries of this row 2, row 3, row 4 of this column 1 into zeros. So what I am writing here? So I am changing the row 2 changes to row 2 minus 2 times row 1. Similarly, row 3 changes to row 3 plus minus 1. So with the help of row 1, because in row 1 there is the pivot element 1. And what is row 4? Row 4 changes to minus row 4 plus minus 3 times row 1. So you already know how to make these operations. So after making these operations, I am writing from my note. So it will be your first row is as it is. So this is your 1 2 4 1, then separated by dotted line. This is 4, and your second row is 0 minus 4 minus 9, 0 minus 4 minus 9, minus 5, minus 4, minus 5, minus 4, and your third row is 0, minus 4, minus 5, minus 4, minus 5, minus 1, minus 4, and your third last row is 0, minus 5, minus 13, 0, minus 5, minus 13, minus 8, minus 7, minus 7. And similarly, your next step is to make the second entry of second row into 1. So what I will make here? So to make this change, so I will multiply in row 2 into 1 by minus 1 by 4. Now I will write your row 2 changes to row 2 into minus 1 by 4. So now write this is 1, 2, 4, 1, then 4. Then after multiplying minus 1 by 4 in row 2, what we will get? This is 0, 1, 9 by 4, then 5 by 4, then 1. And third and fourth row are as usual. So 0, minus 4, minus 5, 0, minus 4, minus 5, minus 1, then 4, sorry, minus 4. Then last row is your 0, minus 5, 10, minus 8, minus 7. So now this is your pivot element. So this pivot element is present in row 2. So by using or with the help of row 2, you have to make the other entries of this column into zeros. That's why I will write your row 1 changes to row 1 plus minus 2 times row 2, and row 3 changes to row 3 plus 4 times row 2, then row 4 changes to row 4 plus 5 times row 2, because pivot element is in row 2. So with this help of row 2, I will make other I will make the other entries of this column into zeros with the help of row 2. So after making these changes, what you will get? The first row will be 1, 0, minus half, minus 3 by 2, then this is 2. Then 0, 1, 0, 1, 9 by 4, 5 by 4, then 1. Then third row is 0, 0, 4, 0, 0, 4, 4, 0. And the fourth row is 0, 0, 0, 0, minus 7 by 4, minus 7 by 4, minus 2. So now this is converted into 1, 0, 0, 0, then 0, 1, 0, 0. Now our next time is to make this entry. This is already 4, so we have to make it 1. That's why I will multiply 1 by 4. So row 3 changes to row 3 into 1 by 4. So now these rows are as it is, then in row 3 we have to multiply 1 by 4. So write it 1, 0, minus half, minus 3 by 2, 2. Then 0, 1, 9 by 4, 5 by 4, 1. And the third row is multiply 1 by 4, 0, 0, 1, 1, 0. 0, 0, 1, 1, 0. And the fourth row is as it is. This is your 0, 0, minus 7 by 4, minus 7 by 4, or minus 2. So now third entry of third row is, sorry, not this one. Third entry of third row is 1. So this is in row 3. So with the help of row 3, we will make other entries of this column C3 into zeros. That's why we will make these operations. Row 1 changes to row 1 plus half times row 3, because here is minus half, that's why I have written here plus half times row 3. Similarly, row 2 plus 9 by 4 times row 3. There is plus 9 by 4 times, that's why I have written minus 9 by 4 times row 3 to make it zeros. Then row 4, and then row 4 plus 7 by 4 times row 3. So after this row first, so what we will get, this will be 1 0 0 minus 1, and this is 2, and this is 0 1 0 minus 1 0 1 0 minus 1 1, then 0 0 1 1 0 0 1 1 0, and the last one is 0 0 0 0 minus 2. So this thing cannot be further reduced, because this is 1 0 0 0, this is 0 1 0 0, then third column is 0 0 1 0, and in the last row this thing already 0. If it is a non-zero, then we can make it 1. Then after making it 1, you can make the other entries of this column into zeros. But since it is 0, this thing cannot be reduced, further reduced. So which is the which cannot be reduced, which cannot be reduced further. So if you will see the corresponding, means if you will see for the solution, if you will see the rank of the coefficient matrix, then what will be the rank of coefficient matrix? This is your coefficient matrix. So what is its rank? Only 3, because this is a non-zero row, this is a non-zero row, this is a non-zero row, but the last one is just 0 row. So this is 0 0 0 0, all entries are 0. So this is a 0 row, so rank of A is equal to 3. But if you will see the rank of A comma B, that means your rank of augmented matrix, consider the full matrix. So this is your this is a non-zero row, this is a non-zero row, this is a non-zero row, this is also a non-zero row, because 0 0 0 0, and the last one is minus 2. So since a non-zero element is there, so this is a non-zero row, so the rank of this one is 4. So these things are not equal, thus the system is inconsistent, or the system of equations has no solution. It has no solution. Okay, you got it? If you will if somebody will find its corresponding system of equations, since after the row reduced echelon form, if you will go to its system of equation, so what you will got from the last line? If you will go to the last line, so what you will got there? So this thing makes your difference. What is this one? 0 from the last row. 0 times x1, 0 times x2, 0 times x3, 0 times x4 equal to minus 2. Is it true? Because the last row is 0 0 0 0 minus 2, and these 4 zeros are the coefficient of x1, x2, x3, x4, and the right one is 0. So 0 times x1 means 0 0 0 0. So if we will add 4 times 0, whether it is minus 2, it is not. That's why it will not give any solution. So the system has no solution. That means it is inconsistent. This one equal to -2 means which is absurd. That means it is asambhava. Okay, today is only this much. If you have any doubt, then ask me.